Sarah doesn't like everything.
It is fun. When you work there, you go on the computer. We have like, I don't know, we had like 2 hours. You go to Simi Valley. You know Simi Valley. There's nothing there. You usually just go to CS project. Yeah, we did finish. Yeah. Yeah, thanks. What are you doing? Okay. Are you guys doing that? If you're actually making it for a second. What is that? Oh, okay. Is it really hard class? I'm thinking about taking that next semester. Is it really hard to get? Is it really hard class to get?
I don't know. I like the slides.
All right, so today there's no quiz that you guys have to do. So make sure you get the lecture code down before I start.
2-8.
Yeah, refresh.
You just got okay. Just I put it on there.
Okay, so everyone got the lecture code? Yeah. All right. So today we're gonna talk about relational databases and SQL. So in terms of the entire schedule, what we've done is we've decided to shift away from PHP for a week. So next week, Alan's gonna continue on teaching more features of PHP and more stuff related to that. But what he's gonna be teaching is gonna be very related to databases. So this week, I'm gonna be talking about databases and how it fits into the structure of the internet and how you would be able to interact with databases. Okay, so today's lecture, today's agenda is just a lecture, and then what is a pretty short lab, at least relatively. So it shouldn't be too hard. So one of the announcements we have is later on this week, we're going to be releasing final project specifications, and the final projects are going to be consist of having pairs of students work together to create an idea or a website of whatever you're choosing, as long as it meets like a few very easy requirements, like having a form, probably doing a little PHP and stuff like that. It's not going to be very stringent requirements, so it's very open-ended. You can pretty much do whatever you want in terms of how you want to design and where you want to go into. Okay, so in the scope of the class, we've talked about HTML, CSS, JavaScript. Those are all client-side technologies. And last week we started jumping into the server side. We talked about PHP, and if you remember, one thing we said about PHP is that it's not necessarily the only server technology out there. There's other stuff like Ruby on Rails that's becoming very popular in the web development space, and a lot of startups start using it. For example, Twitter uses a web framework called Ruby on Rails, which is basically, it takes the place of what PHP does. Google uses some other frameworks. There's a language called Python. And basically this section of the internet can be replaced by different types of technologies. PHP isn't the only technology. So today we're going to be talking about the stuff behind PHP, the information that gets stored into a database and that PHP interacts with and retrieves. So what is a database? According to Wikipedia, a database is a system intended to organize, store, and retrieve large amounts of data easily. So what does it do for us? A database does a lot of things. For example, it allows us to store a lot of information. For example, username, passwords, product tables. So for example, in Amazon's case, their databases would store a bunch of products, listings, and Twitter would store like tweets, usernames, and all those types of things in their databases. And you can sort of think about databases as a bunch of Excel tables in a way. So that's probably like the closest thing it relates to that you probably use at least once in your lifetime or a few times in your life. So where does it fit in? So if we go to something like Google Maps, what we have here is an image that Google Maps pulls, our client browser pulls from the server. And on top of that, we get this extra data that's supplied to us by a server. So this data, as you know, if you go to Google Maps, is overlaid on top of it, and it's completely interactive. And Google decides to store this extra information into a database. So they would store like stuff like stores in some GPS coordinate location, and these things would be all mapped with basically longitude and latitude coordinates in a database. So other use cases for databases is banking. So when you go to Wells Fargo or Bank of America, all of that data and all the transactions are being dealt with using databases. And when you make reservations through Southwest, through hotels, all those are also done using databases. And one other thing that you probably don't notice is your browser also uses databases to some extent to be able to maintain data, for example, some user settings, and also to cache certain elements so that they can be retrieved faster on the internet. So databases are everywhere. And any web technology used today, as long as it's dynamic and it contains data, is going to use a database. So in terms of the mapping, the way a database fits in is, on this side you have the client, and then you have the internet. And here we have a server. For example, we have the PHP server that we talked about in class. And the PHP server is the PHP server then talks to the database. So one thing that you have to keep a note of is that the client itself never directly interacts with the database. It has to go through the server first, and the server then interacts and sends requests, looks up stuff in the database through itself. So the client never actually directly touches the database. And that's one important abstraction that you have to keep in mind, because if a client were able to interact with the database directly, then you would have a lot of security issues. So, for example, someone could randomly change your password or look up your email address. So a lot of spam bots would be able to basically start grabbing your emails and spamming it. So the PHP server allows us to add some security features on top of it. For example, checking what kind of user this is, making sure they're logged in, making sure they have the right permissions in order to access this database. Okay, so I've been talking about databases, and one thing I want to talk about specifically that we're going to discuss in class is something called relational database management systems. It's a really big term, but basically what it is it's a type of database that allows us to relate information, a table of information to another table of information, or other tables of information. So this is the most popular type of database used today. There are also other types of databases, which I list there. They're a little more specialized, and some of them are outdated for their purposes. But you just have to keep in mind that relational databases is the main type of database we use today. And what relational databases allow us to do is access data through tables without having to sort of hard code the relationships between them. And I'll explain more about what this means here in several slides down. Okay, so with relational databases, we actually have a lot of different types of relational databases that you can use. So just like how PHP, on the PHP side, there's a lot of different types of alternative technologies you can use instead of PHP. The same thing goes with databases. So we have like sort of 4 of the most popular databases used on web today. We start with MySQL, and then this thing is called, this is pronounced Postgres, and then you have SQLite, and then Microsoft SQL Server. And there's a lot of like sort of minute, small differences between them, but for the purposes of this class, they're pretty much the same. And one thing though you have to keep in mind is that these 3 databases right here, MySQL, Postgres, and SQLite, are databases that are offered through open source means, meaning that if you wanted to use those databases as part of the back end of your website, you wouldn't need to pay to have that software. If you use something like Microsoft SQL Server, you would have to buy a license, which costs a ton of money. Definitely something probably something you don't want to do, at least at a startup level. All right, so we're going to take a look at what a database kind of looks like. Here we just have one table, and each table begins with several columns, and each column is headed with a title. So this column over here has a title called PID, and this has the column name and price. And each column contains a certain type of data variable. So in this case, this column is of the type integer, meaning that whatever goes into this column can only be an integer. You can't, for example, put in some random words as the ID for this cell. That wouldn't be allowed because the type is integer. In this case, we have a varchar, which stands for variable character, and basically allows you to put any type of text into there. Characters, numbers, punctuation marks, all those types of things. And it's kind of limited in how much text you can put. But that's basically what it allows you to do. And then we have here the price, which takes in a decimal form because we know it can't be just an integer. Prices sometimes like end in 99 or 89 or whatever. So for this column, the type is decimal. And the name of this table for future references is called products. So one thing about database tables, that's kind of a rule, is that for the ID of a table, it has to be unique. So in this case, we have a products table, and each row is distinguishable by a different ID. So if you were to add another row into this table, you have to make sure that the ID is not already taken. So that primary key allows us to be able to uniquely identify a row in a table, and by doing so, we wouldn't have the issue of like what happens if you wanted to pick off a row with ID 2 when there was 2 rows with ID 2. So you wouldn't have that issue if you have your primary keys unique. All right, so this is sort of an overview about what I talked about earlier, and yeah, you can read that later just for your reference. I wrote it down. Okay, so we're going to talk about, give some better terminology, better definitions of what I just talked about. So we have something called the primary key, which was the unique identifier for a table. So that unique identifier is unique upon each row. So each row would have a different primary key. So a primary key uniquely identifies each row table, and so it can be, one interesting thing is that it can be part of the record itself, or it can be an artificial field. So what I mean by that is that if you look back up here, this identification here doesn't actually have to relate to whatever your table is about. As long as the key thing is that to have this this column be some sort of unique identifier. So if, for example, in your table, you wanted to only sort of uniquely identify things by a name, you could do that, but you would also have to have some sort of arbitrary parameter or column here to also uniquely identify the rest of the table. All right, another thing is foreign keys. I haven't showed you this yet, but it'll make sense in a couple of slides down. So a foreign key is basically just a primary key that's used in another table. So just keep that in mind. It's not going to make sense yet. All right, so we're going to talk about examples of what these relationships are. So the best way to probably relate to relationships is thinking about human relationships. So here we're going to try to model relationships between boyfriends and girlfriends. So right here we have a girlfriends table, and this GID stands for girlfriend ID, and each of those girlfriends have a unique ID and a name. Same thing goes for the boyfriend side here, but one interesting thing here is that we have this extra column. And this extra column is what I referred to as a foreign key earlier. And this extra column establishes the mapping between which boyfriend is whose girlfriend. So in this case, GID for Bob is 3. So if we take a look, if we try to look for the GID that matches here, we'll see that Jane is Bob's girlfriend, right? Which is denoted by the arrow there. And the same thing is for Kensington and Billy. So that's how those mappings work, and they're able to be mapped using this foreign key here. So it's important to have this here, this column here, because if you didn't, you wouldn't know what was the relationship status between the boyfriends and the girlfriends. Okay, so now we're gonna do something a little tricky. What if Portia decides to seduce Billy? So what would happen is, oops, I don't know if you guys saw this, but so what happened was, we see here that Billy had a girlfriend ID of 1, and after Portia seduced him, Billy had a girlfriend ID of 2 to map to Portia. So in the end, the mapping becomes like this, where Portia has 2 boyfriends, Kensington and Billy, and Jessica's kind of left alone. So Jane still has her old boyfriend. All right. So then, now we're going to take a look at what happens if Bob decides to also get another girlfriend. So that's the mapping. And if Bob decides to have Jessica as his girlfriend, so the question is, what happens if Bob decides to have Jessica as his girlfriend? What happens to that GID? Someone tell me? We still have Candy, by the way.
While keeping Jane as a girlfriend?
Yes. Anyone know? You don't have to answer right. You can just look at the candy. Yeah?
Is that 1?
What's that?
Is that 1?
1? The short answer is no. So, if we notice here, what we've done is we've created multiple mappings, right? That means one boyfriend can have multiple girlfriends, one girlfriend can have multiple boyfriends. So, using this foreign key column here, we created a problem because we can't assign Bob both Jane and Jessica. So, the solution to that is to create a separate table to uniquely map the relationships between the boyfriends and girlfriends. So here, we decided for the girlfriends to just keep it simple, have the girlfriend ID and the name, and the boyfriends is just boyfriend ID and name. And then in the relationships table, what we have is 2 columns, the GID and the BID. And these 2 columns are foreign IDs. So this one refers to this thing, and this BID refers to that BID. So we can see that using the mapping we had earlier, that this is what the table would result in. So Portia and Kensington have boyfriend, and then, so Bob and Jane still become in a relationship, and Bob and Jessica also stay in a relationship, using this sort of representation of the data. So just a quick overview. Earlier when we had, in the first try, when we were just having one girlfriend to one, or when we had Portia seducing Billy, we had a mapping that was a relationship mapping that was one to many. So one girlfriend could have many boyfriends, but not the other way around. So the second time when, Bob tried to add an extra girlfriend, we created a different type of relationship that was a many-to-many relationship. And when you have a many-to-many relationship, that's when you know that you have to have an extra table in order to maintain track of the relationship between the other two tables. Okay, so I've talked a lot of really high level about how sort of databases work and how they relate to each other. Now we're going to talk more about how you actually communicate the things you want to find and the things you want to do to a database. So for relational databases, a lot of them use something called structured query language to communicate. And structured query language earlier is just acronym SQL or SQL. And it's just another type of, I guess you could call it sort of a programming language that allows you to interact with the database. So in order to interact with the database, you basically need sort of these four types of statements. And what these statements are together, they're all called CRUD. And it stands for create, read, update, and delete. So with the databases, create allows you to insert new rows into the table, basically creating new rows. So the syntax works like this. You have these keywords insert into that always have to be there. And then what you put here is the table name. And then for the values, you would put, So for the field, you would put the name of the columns that you're talking to. And for the values, you'll have the values that map to those field values. It'll be a little bit more clear in a couple examples. And for read, what read does is it allows you to read a selected row or rows off of a table so that you can, for example, pull up the price of a Tonka truck in a products table. So here, it starts with select, and then you have different fields. Fields are also known as columns in this case, from a particular table or tables. And then you have this keyword where. And what where does is it allows you to supply a condition. So that condition basically allows you to be more specific in which rows you're selecting. And you can also have an and keyword that can add extra conditions to what you're trying to look for. So the other thing is update, and update allows you to modify an existing row in a table. The way this works is you have the update keyword, you select you give it the table name, and then you have set, and then you have the column name that you're referring to, and then you put an equal sign, and then what you want the value to be changed to. And you have to make sure to, a lot of times, you don't want to set the entire table to a certain value, so you want to be able to select particular rows first before you update that value. So for delete has a similar form. You delete from whatever table on some kind of condition. So I know some of you guys were confused about this before, but these sort of carets and stuff are basically placeholders for variables to be placed into there. So it's just a way, it's like a computer science convention to do that, so that you know the difference between what's the keyword and what's values that you actually input. Okay, so here we have an example of create. And we're going back to the products table that I showed you earlier. So if we did enter into, this is the, products is the name of the table, and these two are the field names, name and price, the values, mini, Tonka truck, and the price 13, what would happen?
We would just add like a row with product ID 4, name, mini Tonka trunk, and price 13.
Yeah, exactly. So it would basically add this extra row here. It'll automatically assign the ID, and we'll just put in the mini Tonka truck as the name and 13 as the value. So now we have a read. So if we were to run this SQL query statement, select name and price from products, does anyone know what would happen? By the way, just a reminder, whatever goes in between here, the select and the from, basically specifies which column names you want to show up. Yeah.
It's the same table but without the PID.
Right, exactly. You would basically get results that look like this. It just gives you the product name and the price. Because you didn't select the PID, it didn't give you a PID in the results. Okay, so now we're going to have an update example. So we have update and the table that we're going to update, which is the product table, and we're going to set a price to $100 for if the row has a name equal to the Tonka truck. Does anyone, so you want to answer this question?
Sure.
What would happen?
So where it says Tonka truck, what is that? What's Tonka truck?
It's did you have a truck?
No.
It's like it's one of those toy trucks. It's like a construction truck, like one of those huge or like cat trucks, but miniature. It's like yellow.
Where it says Tonka truck?
Yeah.
In the table it would say
Where?
under, like, after this.
Here?
Yes.
Okay, not quite.
Oh, wait.
Got it.
Where it says Tonka. So it
Right.
selects the
Yeah.
Tonka truck.
So what this would do is it would update the price for the Tonka truck to $100. Alright, so now we're going to do a delete. So once again, delete from the table name, in this case products, where the name equals Tonka truck. What would happen? No one, this is really easy. You get candy.
Ask a question, like ask a question on the
Question?
last page, Joseph.
On the last one?
Yeah, like if you didn't specify a where, does it reset everything in the price column to 100?
Yes, exactly.
Okay.
So if this line or that section of the line didn't exist, everything like starting from here on, then all the prices of the table would also be set to $100
Okay.
because there's no condition that it needs to set upon.
Just to confirm, it's not case sensitive.
Yeah, right. So one thing I forgot to mention is all these keywords here, like this update, set, and where, the stuff in bold, are not case sensitive. So this could be all lowercase or like mixed and matched. It doesn't matter. It'll still work. The only thing that matters that's case sensitive is when you, I think when you, okay, so definitely when you specify some value that's in a string like that, or I think also product or the name of the table, and also the name of the
Yeah, that's actually what I was asking. The names in the entries in